All right, so we have 3 more types of reactions we are going to talk about. Single displacement, double displacement, all right, and then redox reactions. This last group, all right, there's really one question you're going to see related to that. So the single displacement and double displacement are a lot more meaningful. And those should be kind of added to a list with the synthesis, decomposition, and combustion reactions where you can easily identify them and what's going on with them and how to balance them. Redox reactions kind of fall into this separate other category that we'll talk about at the end. So, double displacement. So double displacement means that you're going to have parts of 2 compounds that switch spots to form 2 new compounds. All right? So really what I want you to do is kind of look carefully here. What you've got is the metal, or the first element in these 2 compounds, switching spots with each other. All right? Because it starts out with A attached to B, and C attached to D, and then afterwards you can see that A and C switch spots with each other, because now C is attached to B and A is attached to D. Alright? If you look at this other kind of picture up at the top here, you can see that it's the guys switch their hats. Okay? So you're just taking kind of like half of each compound and switching spots. So let's see if you can spot the double displacement reactions. So remember, we've got AB plus CD yields AD plus CB. All right. So couple of things you can do to help yourself kind of narrow things down is that you should have 2 reactants and 2 products. All right, so we can say this first group, I can easily get rid of these 2 because those have 1 reactant or 1 product. All right, the next thing is the next 2. These both have 2 reactants and 2 products. So now we got to look a little bit closer. Which one has 2 compounds that are switching spots with each other? All right. So, and by compounds, that means there has to be more than 1 element present in the chemical. All right, so like C2H6 is a compound, but oxygen's not. So there couldn't be any switching here. All right. Whereas if you look at this top one, we've got copper attached to chlorine, sodium attached to OH, which is the hydroxide ion. All right, if you look at how things are attached afterwards, sodium is now attached to chlorine and the copper is attached to the OH. So they switched. So A is your correct answer in the first one. So looking at the next group, again, if it doesn't have 2 reactants and 2 products, I can get rid of them. All right, and then you just, when you get to ones where they fit the 2 reactants and 2 products, look carefully at what's going on. All right, you need to have 2 compounds where half the compound is switching spots with each other. So again, oxygen, not a compound. So C's not going to work either. Here, we've got sodium and magnesium switching spots. Okay. All right, let's do a quick review on balancing with one of these. Let's see, we're going to have 4 columns. We have 4 different atoms. We've got magnesium, phosphorus, silver, and chlorine. And this is where it does come in handy to write these out in the same order as your reactants, even though that's not going to be the order that they show up in the equation, because it makes it easier to see when things become even. So I've got 3 magnesiums, 2 phosphori, 1 silver, 1 chlorine. Got 1 magnesium, 1 phosphorus, 3 silver, and 2 chlorines. All right, so I'm going to try fixing magnesium first. So that's going to put a 3 here, because I have 3 in the reactants, but only 1 in the products. And then I'll turn this into 3, and that's going to turn my chlorines into 6. All right, so magnesium is balanced. Phosphorus. I'm going to throw a 2 out front here. All right, because that's going to double my phosphorus and get those to be equal on both sides. That 2 times 3 silvers is going to turn it into 6 silvers. All right. So now let's try to fix silver. I have 1 in the reactants and I've got 6 coming out. So I'm going to put a 6 out front here, which is going to turn both the silver and the chlorine into 6 each, and that actually fixes both of those molecules. And now our equation is balanced. All right, so single displacement is very similar to double displacement, but instead of there being 2 compounds that switch half of their spots, you've got 1 compound that just has half of it kicked out and replaced by a solo element. All right. So let's look at some examples here. So we're going to have a solo element and a compound, and then a different solo element and a new compound, where these switch spots. So again, there should be 2 reactants and 2 products, so we can start with some of the same narrowing down as we did before. So those are no good, because those have either 1 reactant or 1 product. These next 2 have 2 reactants and 2 products. So now we got to get a little bit more detailed into what exactly is there. All right, so we do want our reactant should be an element and a compound. All right, so far these both match that. And then our product should also be a different element and a different compound, which means this one doesn't work because those are both compounds. All right, and you can see D matches what's going on here because you got the copper and the silver switching spots. All right, so copper was on its own with silver attached to chlorine. Now silver's on its own and copper is attached to chlorine. So D is the correct one there. All right, so next one, I'm going to start by removing anything that doesn't have 2 reactants or 2 products. This only has 1 product, so D doesn't work. Everything else has 2 and 2. So now I've got to look a little more closely at what I've got going on. So I want things that have a solo element and a compound in reactants. So that can help me get rid of A, because these are both compounds. That would be double displacement. All right, and I can narrow things down even further when I look at my products, which should also be a single element and a compound. And this one has 2 compounds. All right, so here, magnesium and sodium switch spots. So if you're having issues identifying any of these, because I mean at this point you should be able to take any of these equations and just identify what they are. All right? So if I were to erase all of this stuff, you should be able to tell me that this top one is double displacement. All right, we just identified this one as single displacement. B, because it has oxygen as a reactant and carbon dioxide and water as products, is combustion. And then my last one, we are taking two elements and then smushing them together to make one more complicated product. That's synthesis. All right, so you should be able to do stuff like that now. All right, so last thing I want to do is go over oxidation, redox. All right, so this is the whole redox thing, which stands for reduction and oxidation. I think oxidation is a little easier to see at first than reduction. But this has to do with ionic compounds and what's going on with the atoms and their electrons. All right, so if something undergoes oxidation, it loses electrons. All right, you can also think of it as it becomes more positive. So in this example here, magnesium is oxidized. The way to kind of tell what's going on is you want to write your charges down. All right, so magnesium on its own is neutral. All right, sodium and chlorine, they are in an ionic compound. We're dealing with +1 and -1. All right, and then sodium on its own on the product side is going to be 0. It's neutral. It's not in an ionic compound anymore. And then the magnesium is +2, and then chlorine's still -1. All right, we just needed 2 of them to get to the charge to cancel out. So you can see that magnesium was oxidized because it went from being 0 charge to +2. It became more positive. Reduction is the opposite of that. In reduction, you gain electrons, all right, or become less positive. Or more negative, maybe. But usually it's less positive. All right, so again, thinking about what we had before, which element became less positive? All right, Na went from +1 to 0. So sodium was reduced. In terms of what you need to be able to do, you're going to see a question like, I'm going to go like this one. All right. And you're going to be asked which element is oxidized and which is reduced. So oxidize. All right. You're going to increase your positive. Reduce, you're going to decrease your positive. So if you look at our charges here, we can see that oxygen stays the same charge. So that's neither. So that's not going to be the correct answer for either question. Aluminum goes from 0 to +3. Iron goes from +3 to 0. All right, so based on that, aluminum is oxidized. Iron is reduced. All right, there's a quiz question on this. This should be enough to give you the answer for that. But if you have any questions about this, just let me know.